Hello, my name is Hector Pariente, and today I'll be presenting my project on graph theory and its importance in today's world. As someone who has worked on systems engineering and is now pursuing a master's in software engineering, I see graph theory as a bridge that links the physical world and the computational one. One of the most interesting things about this specific topic is, for the longest time, back when I was a student, I actually never realized it was something that I was actively using, either unconsciously or it was part of a specific topic that we were looking, but I couldn't make the connection back then until I started learning about discrete mathematics and computational systems, where they illustrated how it actually works and this topic relates to the uh, different sciences, not only the ones that I personally work with, but others as well. Uh, you can find this even in biology and population studies as well. My goal in this presentation is to explain what graph theory is, going through the definition of it, and also to show how it applies across different engineering disciplines. As I mentioned before, there's a lot of different sciences and fields of study that use this concept heavily, but I want to focus on specific scenarios and cases that I work with personally and are also part of the studies I'm taking. So the main applications I want to work with are on engineering side and on computer science and software. Also, I want to describe why learning discrete mathematics in general has been meaningful for my personal and professional development, and the importance in present day society for something like graph theory, and how this concept as well has related to the other um, sciences I'm working with. To understand the topic, I first want to talk about the definition of graph theory, what exactly is, what it entails, what it represents, and how it relates to other types of science or fields of study. Graph theory is known as the study of objects and the connections between them. If it sounds like a broad definition, it's because it is, even though it's an abstract concept that we see in classes such as discrete mathematics or certain um, concepts that we cover on other sciences. It is in reality something that has a variety of applications that can be used under real life scenarios that we have and deal with every day, both on or normal day life and on on the business side of things as well. Um, the formal definition of this, as I say, uh, is objects and the connections between them, where objects are called nodes and connections are called edges. This simple structure is of great importance in the world today because a large number of real life systems can be represented through these specific illustrations, or to say. A graph allows us to take something complex and break it down into clear, understandable components. For example, cities connected by highways form a graph. This is a concept that is always been covered by civil engineering, even before we started using computational systems. Um, they use the complete, like the same approach used on discrete mathematics and computational systems, which is assigning vertex, edges, nodes, weights, everything that we have in a theoretical way, it applies in a real life scenario through civil engineering and transportation studies. Um, Social networks are another example of graphs, where people are represented as nodes and relationships as different edges. In engineering, machines, circuits, workflows, and even inspection routes can all be represented as graphs as well. What makes graph theory valuable is not only the representation, but the analysis of it. Once a system has been modeled as a graph, we can study paths, cycles, connectivity, bottlenecks, and efficiency. This is true for a variety of fields, and also it makes a graph a universal language that engineers and computer scientists can use to understand system behavior and how to solve practical problems. Now I'm going to talk about the applications graph theory has in a variety of fields. I'm going to focus mainly on two broad cases, which are engineering as a whole, with some particular examples and things that actually apply to my own personal level of knowledge, and computer science and software, which is something I'm focusing also my work and my studies, and I can illustrate a little bit better with other examples as well. Graph theory appears in many different areas. One example is structural systems. Joints or support can be represented as nodes, while beams and or members are the edges. This helps engineers understand how loads travel through structure and where stress concentrations might occur. I'm familiar with these concepts thanks to my studies in mechanical engineering, which helped me understand greatly how this system works. Um, when talking about civil engineering, transportation systems are another clear example. Roads, intersections, and routes naturally form a graph. Using graph algorithms, we can evaluate route efficiency, analyze traffic flow, and study how disruptions affect the overall network. Nowadays, I personally work with traffic modeling, and graph-based analysis makes it possible to see movement and congestion patterns in a structured way. I wanted to showcase that by showing this picture here. Um, when dealing with anything that has to do with transportation, it is really straightforward to make the comparison um, into a computational or discrete math system using graphs. As you can see, locations can be represented as nodes, and any distance or path travel can be converted easily into an edge, which can have their own weight, their directions. So it helps to give a really real life scenario to something that we use in the computational approaches. Motion systems as well. This is in mechanical engineering, such as with robotic arms or mechanical linkages, can also be modeled as graphs where each joint is a node and each connecting piece is an edge. This helps engineers predict movement, test reachability, and optimize mechanism design. When dealing with anything that has to do uh, with robotic arms movement, we actually work with uh, matrices of change. So all the calculations can be also translated into graphs. Finally, process workflows in engineering can be expressed as direct graphs as well. Each step is a node, and arrows show the order of tasks. This helps uncover inefficiencies or unnecessary steps. Across all these examples, graph allows engineers to simulate ideas digitally, evaluate alternatives, and identify weaknesses before committing to physical prototypes. Among the sciences that use the concept of graph theory, one of the most important ones and that deal with this heavily in an essential way is actually computer science, just because how computers actually communicate with the world around it, or how we communicate with them. Many of the data that they receive as an input and the output that they provide is based on the idea of graphs themselves. Um, Many core data structures, such as the trees and linked lists, are graphs. These structures make it possible to organize, search, sort, and store information efficiently. Dependency graphs are used constantly in software development. They show how one model depends on another, which help developers understand the impact of changes and avoid breaking the system. An example is a routing algorithm like Dijkstra algorithm that we see in data structure classes. These rely directly on graph theory, um, since these algorithms determine the shortest or fastest path between nodes, which is how navigation apps and network communication and even online multiplayer games operate. Software systems also use Graph to optimize performance, from database indexing to load balancing to analyzing social media interactions. Graph-based algorithms make systems scalable and reliable. Graph theory essentially gives a structure to software logic just as it does for physical systems. Now, I'm going to talk about the present world and personal significance. Graph theory has had, in general, both on, as I can say, on society level and on a personal level, has helped me currently on my work and my studies. I want to cover specific areas. Some of them are similar to what I already talked about, but I want to make a special mention of how these all interconnect and mainly how that affects the current society because I think right now we're in the point in which we're using topics such as graph theory more than ever before, thanks for the to the approach we're having to AI. On the present day importance of graph theory, um, I can give mention on the fact that it is especially important today because of how deeply it is integrated into AI, software, and model engineering as a whole. In AI, graphs help represent relationships, preference, and decisions. Many AI models depend on graph structures for recommendation systems, routing problems, and pattern recognition tasks. AI uses graphs to understand complex relationships quickly and efficiently. And in software, graph theory forms the backbone of algorithm design and system structure, as I already mentioned before. Without it, we couldn't build scalable applications, analyze dependencies, or maintain stable digital systems. So nowadays, there's a really big investment on all industries of the world on trying to move towards the use of AI and automatization. And this has been done using the concept from discrete mathematics and graph theory. It allows us to develop these systems that basically take a branched level of paths and be learning the patterns to find the solutions and become better with each iteration. I also mentioned on engineering how this has been helpful as well, and thanks to the fact that engineering is also taking AI and software automatizations approach, um, it is also becoming a really a central topic on improving these systems in general. Graph model allows us to study transportation routes, optimize traffic patterns, and understand how systems behave under different conditions. Thanks to things such as the simulations that can be provided through machine learning. Graphs help us reveal constraints and weak points, leading to smarter design and safer outcomes. Across all three areas, graph theory gives us the tool to analyze complex problems and make informed decisions in a fast, data-driven world. Discrete mathematics and topics such as graph theory have played a significant role in my personal and professional development. As I mentioned before, I come from a background of mechanical engineering and I now work as a process and systems engineer. I use programming, algorithm design, and data analysis every day. The logical structure behind discrete math has helped me approach these tasks with more clarity and precision. Graph theory has had a direct impact in my work as an engineer in an engineering consulting firm for things such as traffic modeling and network analysis. It has allowed me to understand connections, study movement patterns, and identify areas for improvement. Representing real systems as graphs make them easier to analyze and optimize, and also provides really helpful illustrations and information in general for everybody involved whenever I do something that has to do with flowcharts or representation of workflow. Overall, this field of study has helped me combine both engineering worlds and software and computer science as well, and it has continued to support me as I move towards my graduate level work. It has given me the tools to adapt to new technologies, contribute to interdisciplinary projects, and design more efficient systems. Thank you.